Okay, let's finish up the process of putting in this Bezier curve together. One thing is I made an error before in the previous part. It's not worth redoing that. I was evaluating at t equals pi, which was silly, because the second curve, Alice's curve, was going from 0 to pi, but I wanted 0. I wanted t equals 0 to put things in. And I correctly did that for the position, but for the velocity, I put in I put in 0 for the position, but I put in pi for the velocity. So this actually turned out, when you trace through that error and you redo your R2, turns out that that's a 2 and not a 6. Okay, so what are we going to do with all this information? So remember the master formula for Bezier, R of t is 1 minus t cubed R naught. So it's this beautiful Pascal's triangle binomial theorem kind of pattern. And I didn't record a video about why you get this pattern, but the Wikipedia article does have some nice pictures about where this really comes from. We know it does what we want it to do, though. Okay, so now we're just going to plug that in. Okay. So let's see. Get my cheat sheet here. Okay, so it's 1 minus t cubed, and then R naught is 1, 0, 4.14. And then 3t, 1 minus t, quantity squared. And R1 is 1, 2/3, 4.31. And then 3t squared, 1 minus t, oops, that's a parentheses, not an angle bracket, times minus 1/3, 1, and that's to 2, that was what I corrected. And then plus t cubed, 0 to 4. Okay, so we'll just put those together, and I'm not going to really try to simplify much, because I might as well I don't have to simplify it to put it on the computer. I'm just going to make sure I put it all together. 1 minus t cubed plus 3t, 1 minus t squared, minus t squared, 1 minus t. So that's this contribution, this contribution, this contribution. That one has to be 0. Okay, that's for the first component. And then 2t times 1 minus t squared. That's 2/3 times the 3 there. Okay. Plus 3t squared, 1 minus t. That's this times this. And then plus 2t cubed. That's this times this. Okay. And then the last component, 4.14 times the quantity 1 minus t cubed, plus 12.93, and that's coming from here, t times 1 minus t quantity squared, plus 6, 2 times 3, t squared, 1 minus t, that's a squared, and then plus 4t cubed. Whew! It looks like a mess, but it's not something that's hard to enter into the computer. And in fact, I already did that. I don't want to bore you with entering that in, and I wanted to make sure, I checked it to make sure it looked good. So I just entered the x in, the y in, and the z in. Notice it's rather long. It actually goes beyond the length there. Okay, but I had entered those in. 0 to 1. So remember, with the pieces you create, you can control the t's. With the Bezier, if you're going to use the standard form for the Bezier, it's always 0 to 1. And I didn't put any of this in here. And I already graphed it. You would click graph here. Boom. Okay. And now, ta-da. Okay. We've got something that nicely interpolates. And you want to really look at it from all these angles and see. It should certainly connect. It shouldn't have any jumps or gaps. But what's equally important is that it shouldn't have a sharp corner. And actually, the reason I found out about the 6 that had to turn into a 2 is I went ahead and graphed this. And it had a sharp corner. And I knew that something was wrong, and I knew that it was probably in that R2 because it was a sharp corner at the junction with Alice's piece. And that I could kind of trace back the error with a little difficulty to see where I had gotten a sign error, well, an evaluation error. Okay, so that's the kind of thing we got. We got one piece, and then the Bezier, and then the other piece. Notice it doesn't look ridiculously sharply curved, although it certainly turns pretty darn quickly right here. But hey, it's a roller coaster, so maybe that's all right. Okay, so I think that's pretty much all I want to show in order to do this. You can play with the applet, certainly. I'll give you the URL for it. One thing I didn't get it to do, zooming in and out is not too bad because you've got just these zooms here. It's kind of weird that the axes just change their labels and that box doesn't change. I don't have a good way to just slide it back and forth, to sort of drag it back and forth like one of the other applets does. But other than that, it's pretty darn powerful, and we're going to play with it some more.